Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series, where in the last part we created now our physics world and also created already some box 2D bodies with box shapes that we can see here around our slime and player entity that we currently create out of the world. And in this part, we are going to make something super exciting for the first part, for the first time, which is we are actually moving around now our player with the input on our keyboard. So we move the box to the body of the player. We react on the keyboard input on the arrow keys, for example, left, right, up and down. And that's it, because I want to show a couple of things. So most likely this will be again a longer part like the one before. But with that we covered then, I guess, everything that you need to know for Box 2D for that specific game that we are going to develop. Okay, so let's start, I would say, first of all with the input system. Yeah, let's do it like that. So it's not really an input system, it's a so-called input processor, if I remember correctly, in LibGDX. Let's see. For that I usually create a new package again, which I call input, and there, for example, let's make a player keyboard input processor. Could it be any longer? I don't think so. And why is it a Java class? Am I crazy? I don't want a Java class, I want a Kotlin class. So what does this processor need? So first of all, it needs access to our world. So we will give it that, and we see why we need that in a moment. Then it needs access to so-called move components that we did not introduce yet, but we are going to introduce that in this part. So there we're going to access move components, and that would be it. So let's quickly just create an empty component without any information, just that we have it available. Okay, and this is a so-called KTX input adapter. And what is that? A KTX input adapter is simply an input processor of LibGDX with default implementation for empty implementation for all of the different methods. So in LibGDX, there are different ways how you can react on an input. So on mouse events or keyboard events, you can query for certain things. So there is the so-called GdX input static methods, I call them now, where you can check, for example, is a button, was it just pressed, is it still pressed, was it released, was something touched? So touch would be the mouse event, so things like that. So there you really ask the underlying processing part of the input if certain things were pressed or are pressed and things like that. And then you can also, of course, directly react to those events. So when I press a certain button, then I want to get called by LibGDX that something is happening. And this is done via so-called input processors. And there are certain methods available, as you see here. For example, key down is when you press down the key on the keyboard. Key up is when you release the key. Key typed, I have actually no idea. Maybe that is for phones, when you type something on the Android pop-up phone. Then the mouse event, scroll, touch down, touch drag, all of that. But we, for now, only are interested in key down and key up methods, because we want to move our player when a certain key is pressed. So we want to move him around. So first of all, when we create a player keyboard input processor, then we need to tell LibGDX that this is now the active input processor. And there, again, in this GdX input, you can set an input processor, which is in our case this, so the class itself, which is not perfect. So imagine you might have even multiple input processors. So a typical example would be that with Scene 2D, you have an overlay on the phone, like a joystick and maybe some buttons that the player can press. So that would be one input processor, so the Scene 2D UI overlay. Then in parallel, you might have, if the player is playing on the desktop, you might have the keyboard input processor. And then you want to have actually that both react on these events. And this is also possible in LibGDX. So there is an input multiplexer, exactly, where you simply pass in a list of input processors. So could be then the keyboard input processor, plus in addition your Scene2D UI overlay input processor and things like that. So to be 100% safe, you could check here, is this input processor null? If not, then create an input multiplexer out of it with whatever input processor you have right now, plus the keyboard. But in our game, we know, so there will be nothing like that. So our only input processor will be this one. So we directly set it like this. Then we are going to override certain methods. So we are going to override the key down method and also the key up method, because there we want to react on something and do something. And also we want to do something with player entities. And there is now a new way that you have never seen before, how you can get entities out of the Flex entity component system without having a system, because right now here we don't have a system, but we still want to have access to player entities. And that one you can do like this. So we define our player entities, and there we simply need our world. And for that we need, oh, sorry, I was wrong. I was stupid. We don't need the box2D world. Yeah, that's the problem with this name clash here. We want to have our flex world, because from our flex world, we want to have a family. And our family is simply a family of all of our entities which have a player component, which we also don't have at the moment. I see, oh, we did not introduce that as well. So let's introduce a player component also really quick. That's it. So any player entity, so any player controlled entity, I want to say, will have a player component. And with that, we simply get all those entities which are assigned to a specific player, because those we want to move around with our keyboard. Okay, so key down and key up, similar to the Scene2D methods that we have seen in another part, require us to return a Boolean. And again, it is like that. So if we handle the event, we want to return true. And if we did not handle the event, then we return false. So but default, let's say return false, because we don't react on that. And now we want to do something. And here we can simply do the following. So we want to check, is a movement key pressed? Then we want to move our player. And if a movement key is not pressed, then of course we want to stop our player from moving. And what we get here into this method is a so-called key code, which is an integer. And those are just some numbers for any key that you have on your keyboard. So there's a keys class, and for example, the escape key has, I don't know, some number, 111. Then there would be the arrow keys, or I think it's just called up, down, left, right. So up has, for example, the number 19, right has 22. So those are the different codes that you get passed into this methods, and this is called the key code. So what we want to do, we want to check if the key code is a movement key. Then we want to do something, and we return true. And the same for the key up method. So if a key is released, then we also want to do something with it and return true. So what is movement key? So there we simply make an extension function to make it easier to read. So is movement key. That one returns a Boolean, and it simply returns that this is, for example, up from this keys input up, or this is down, or this is right, or this is left. Okay, like this. So because we only want to react on up, down, right, and left. So those are our movement keys, and there we want to do something. And what we want to do now, there I need to explain a little bit how 2D movement works, or a little trick. So also to explain it to you, my first approach, what I did was a very, how you say that, a brute force approach. So what I did when a key was pressed, so for example up, then I said that the player should move in a specific direction, and there I used the degrees in angles. So for example, for up it would be 90 degrees, for down it would be 270, can that be? For right it would be 0, and for left it would be 180 degrees. So that's very easy for key down. The problem is, what happens if the player presses now multiple buttons, so up and right, for example. Then we want to go, so for example up, right, that would be 45 degrees. So then I had, what I did, I then checked, okay, was up pressed and right pressed, then I set this degree, and in the end I ended up with a very, very large if block to check all the different combinations of buttons that could be pressed and the different angles that I wanted to move. And yeah, totally working, but of course not a nice approach, and very long with this if block, so not ideal. And then I remembered back from my Warcraft 3 mapping times, where I used a lot of 2D movement math, that there is a better approach, and let me explain that to you in a moment. Okay, so I found some nice animation on the internet again, which I will simply use for that video. So in 2D movement, you can imagine like you are going in a specific degree, as I mentioned before, so towards a certain angle, which can be represented as a circle. So if we want to go right, we go here, so to 0 degrees. If we go up, it's 90 degrees. If we go left, it's 180, and so on. If we go up right, 45. And how can we represent that? You can easily do that with the sine, and is it called cosine in English? In German, it's sinus and cosinus. In English, I think it's sine and cosine. So those two functions actually help us with moving a body or an entity in a specific direction, because if we want to go right, which would be an angle of 0, therefore, I guess it's sine if I see it here correctly, so the sine would be 0 and the cosine would be 1, which is actually exactly the opposite from sine, if I remember correctly. So we simply need to set the sine and cosine values, so between 0 and 1, and then simply multiply it with the speed of our entity. So this is how fast the entity then moves towards that direction. But again, we don't need to have all these crazy if block conditions, because our keyboard input is simply modifying the sine and cosine value. So for example, if we press up, then the sine value is 1. If we press down, then the sine value is -1. If we press right, then the cosine value is 1. And if we press left, the cosine value is -1. And if we release any of those buttons, then their sine or cosine value is simply reverted back to 0. And with that, we really don't need any if block at all. We simply set those two values, and then our entities are moving in the correct angle. Another approach would be that you simply add a joystick input to your game, because there, I think in libGDX automatically, the joystick is also simply a little button inside a circle, and depending on in which direction of this circle you move the joystick, you also get this cosine and sine value out of it, and with that you can again easily move your entity around. So let's get back to our code. So again, when we are pressing a keyboard button, then we are checking what kind of key code gets pressed. So we already know it's a movement key, and when it's the up key, then we want to set our sine value to 1. So we did not store that yet. Let's move it here. Or actually we need to remember that, because yeah, we need to remember that, I think. So that's why we store it in the class. Let's think that through at the end when we are done. So we have a variable which is the player sine, which is 0, and then we also have a player cosine, which is also by default 0. Okay, now when we press the up button, then our sine value becomes 1 because we want to move upwards. When we press down, then our sine value becomes -1. When we press right, then our cosine value becomes 1. And when we press left, then our cosine value becomes -1. Okay, and the same thing we do for the up method. So when a button gets released. So there we need to check something now. So if the up button gets released, then the player sine value is either 0, or it could also be -1. Actually, I already see that I did here something wrong. So that should be always an equal. It should be like that. Okay. So again here, so if we release a button, it could be that when we release the up button, that the down button is still pressed. So then we still need to set it to -1 instead of 0. So what we need to do, if GDX input is key pressed, and we check is the down key pressed. If yes, then it's -1, and otherwise the sine value is 0. Then the other way around. So if the up button or the down button gets released, then we check is the up button still pressed. If yes, it's 1. Otherwise it's 0. Then here we need to check when the right button is released, is the left button pressed? If yes, it's -1. Otherwise it's 0. And here we need to check is the right button pressed, then it's 1, and otherwise it's 0. Okay, and with that piece of information, we could then afterwards, so after we have set those values, we can update the player movement. So that will be a new function that we introduce now. Let's define that here. So update player movement. And here we are going to iterate over all the player entities. And we, from the movement components from our player, we will then set those directions. So our movement component, we already know that now. It needs the cosine and sine value that we know in which direction we should move the entity. So with that specific move component of that entity, we set the cosine to the player cosine and the sine to the player sine. Like that. And let's now update our move component. So that could be a data class with a cosine, which is a float, and a sine, which is also a float. And that's it. Okay, so with that should be it for the movement system part. So that's why we also need to remember this player sine and cosine values, because we're reacting on just one key, but we still need the value from the other keys. So for example, if we press up, we would still need to know, did the player press left or right before? So what was the correct cosine and sine value when we update the player movement? So that's why we need to store it as an attribute of our input processor. And now the only thing that we need to do is when our screen gets shown, for example, like here, then we simply, maybe here at the end, we are creating this player keyboard input processor. And we pass in the entity world, and from our entity world, also the mapper. Okay, then coming back to our move component, what else do we need? So with that piece of information, we would know in which direction we want to go. Then we also need to know how fast should our entity move. So that would be the speed. And for now, that should be it. So later on, we will add something in addition here, but for now, that is sufficient. And with a move component, of course, we also need a move system. And this move system is now iterating over all entities which have a move component and also a physics component. So since we are working with Box2D, all our movement is happening throughout the physics engine. Good, and there we, as always, need access to those components usually. So we need access to the move components. And we need access to the physics components. And it is an iterating system. And what do we do now? So first of all, let's get our component. So we get the move component. And we get the physics component. And now again, there is some math happening. So in Box2D, when you want to move a body instantly at a specific speed, you need to apply an impulse to the center of the body. So there's some documentation. A very good one, I think it's iForce2D. Let me quickly check. Yeah, exactly. So I remember that one. So I will add the link also to the video description below. There you have a lot of good documentation. So what is a body fixture, the world settings, how can I jump, how can you prevent that you are jumping in mid-air. So all this stuff is documented there, sensors, things like that. And there's also the documentation for this movement that we are going to cover. I think it's this moving at constant speed that we are going to use. And how does it work? So first of all, when we are in our move system here, we are going to check from our move component, is the cosine value 0 and is the sine value 0. That means that our entity should not move anymore because there is no direction specified. So we want to stop entity immediately. And how does that work? There we need to apply now a certain impulse again, which is dependent on the current speed of where the body is currently moving and also its mass. So what we need here is that we need the mass from our body. Then we need its speed, so the velocity in the x and y direction, which is also stored on the body, and it's the linear velocity. And then we want to apply an impulse. And currently we cannot do that because we could do that here directly. So to our body, I think it's called apply force, apply linear impulse, but we don't want to do that outside of the physics simulation, let's say, so outside of our physics system. We really want to apply an impulse only once when the step method is called. So the solution what I did there to make that happen is that in our physics component, which currently only has the body, there we add an additional information, which is an impulse that we are going to apply then each step, and this is simply a vector 2. And now what we can do, so with this impulse, currently it's just available, we are going to set it. And the value that we need to set it is, it's the mass times 0 minus the current speed that it has on the x direction. And for the y coordinate, it's the same. So we want to stop the body, so we need to remove the current velocity that it has to stop it. Okay, and then in that block we are actually already done. So if we don't want to move into any direction, then we stop our physics body. Currently we don't do anything with this impulse, but we do that then in a moment. So below here we know that we want to move our body because either cosine or sine is not 0. So again, we need the mass of our physics body, which we can, since we need it everywhere, we can simply extract it here at the top. Then we have it also available below, which I think is fine enough. And the velocity we actually also need, so let's also extract that at the top because we need that below here as well. And now we set the impulse in a different way. So now it's actually the mass times from our move component the speed times the cosine value on the x direction. And on the y coordinate, it's also the speed times the sine value of our movement. And similar to above, we need to remove also the velocity that the body currently has to really bring it exactly to the speed that we have here. So if it would be faster, it gets stopped to that movement, and if it would be slower, then it gets simply increased to that specific speed. Okay, and why does that work again? So let me quickly go back to the graphic that we had before. So as you can imagine here, so if we would have a movement, let's say of 10 units per second, so we would move quite fast. If we have a cosine value of 1 and a sine value of 0, then we simply would move. So when you add this to your x and y coordinate, then you end up moving to the right. And if you would have a sine of 1 and a cosine of 0, and you multiply the speed and add that to your x and y coordinate, then you simply move upwards. So that's why that is working. And that is the math behind that. Good, so this is also the MoveSystem. Let's add that to our game screen. When do we want to have the movement? I would say before the PhysicSystem, because there we calculate an impulse that is then applied inside the PhysicSystem. And when we go to our PhysicSystem, so how do we now apply this impulse? So there, in our onTick entity method, where we set the position of the graphic, there we now do something special. So if from our physics component the impulse is not 0, is not 0, no, there is only a 0, So if it's not 0, so we want to apply an impulse, then we are going to do that. So from our body, we apply a linear impulse, because that is the one that we defined. We also going to apply that to the center of our body. And in case the entity would sleep, we would also wake it up, so that something happened to it. And then we simply reset our impulse to 0, because it was now correctly applied for that, for the next step, or for the current step of the physics world. There's actually a set0 function from... it's actually libGDX itself. Okay, so we can use that to reset our impulse to 0. Okay, what is that part here? So why do we apply the impulse to the center? You could theoretically apply a force or an impulse in box 2D anywhere else on your body, to, for example, also make it rotate. So if you would apply a force to a corner of a box, then of course the box would rotate. In our case, that does not make sense, because we anyway have a fixed rotation for our different boxes. And also, I think if you want to move a body with the formula and the logic that we are using, then you really need to apply that impulse to the center of the body, that it's working correctly. Good, and that should theoretically be it. Let's try that out. So now when we start up our game and we press one of the arrow keys, then already our body should move around. Which it does not. Why doesn't it do that? Let's see. It's quite obvious when we debug it. So our player entities are empty. So we don't update the movement for any entity in our input processor. And the reason is, it is the player component, which we do not add at the moment. So let's go back to our spawn system. And there we want to check now something. So if, how is it called? Type, I think. Yes. So if the type is a player, then we want to add the player component to such an entity. Good. And then I also saw something there in the input processor. So we don't need to store the word, because we actually never use it again. So we simply can pass it in like this, because we just want to get the family out of it, so we don't need to store it. Also good. Okay, so now it should work. And it still doesn't work, so we crash with flex no such component exception. You see that now also for the first time. And the exception tells us it does not have a move component, which is also correct, because we forgot that as well. So in our spawn system, any entity needs, of course, a movement component as well, so that it can move around. And there we want to do now something special, because a movement is configurable, so not every entity moves at the same speed. So in our spawn configuration, where currently we add only the model, we also apply, or we also define the speed at which an entity moves around. And the approach that I use there is that you don't specify a specific speed value. What I did there in that specific game is that I always use a scaling value. So speed scaling would be 1, and then I simply have a default value. So for example, default speed in my game would be that entity moves, for example, 3 units per second. And then with the scaling factor, you can define how much faster or slower a specific entity is. And why did I choose that approach? Because I thought in a bigger game, fixed values could be a problem, because maybe at some point in your game you notice that, I don't know, the value 10 is not good enough. You need to increase everything by 5 or 10 or whatever. And if you have fixed values, then in all the configurations you would need to add that specific value. And if you have a setup like this, then you simply increase the default speed. So maybe our game is too slow. We want to say that every entity should move 2 times faster. Then we just set it here to 6, and that's it. So we only need to adjust that once. So that's why I used here this scaling factor. Let's move the constants up here and now go back to our EntitySpawnSystem. And here, so our move component has a speed, and the speed is now the default speed times from the configuration the speed scaling. And also we want to check here something. So if the speed scaling is greater 0, only then we are going to add the move component. That way we can also configure that, for example, for the chest entity that we are introducing later on, that one will have a speed scaling of 0 because it cannot move. And when it cannot move, then it simply does not get the move component. So this is how that is solved. And now I'm pretty positive that it should work. And ta-da! We can move around. And what you see already, so with Box2D, we can actually now move the slime around. For the first time, we also see that we have a foreground layer in our map. So things really disappear behind the tree, and in front of the tree, we are in front of it. And yeah, you see already this magic and benefit, I would say, of Box2D. So we can already interact with the different bodies of the world. Of course, we don't want that. So we don't want that our player actually moves slimes around. At least I did not want to do that. I wanted that the player is colliding with the rock, the fence, and with the chest. But with normal enemies, I wanted that he can simply walk through them. And that is something that we are going to solve then in an upcoming part. So for that part, that would be it. So finally we can move around and do something. Later on, we will also introduce that the player is looking, or any entity actually, is looking to the left when it moves to the left, that also the correct animation is played when we move around. But for the time being, we focus on the physics engine part, so the Box2D part. So that's why we do it like that. Okay, so that's it for this part. And now only one thing is left for Box2D. Then we are actually through. Actually, two things. So one thing is now this collision handling. So how do we react on such collisions? There we are going to learn a few more things. But for now, the last important part for me that I will focus on in the next part is the rendering. So for now, actually, our image is always exactly the position of the physics body. And let me quickly change something in our setup, then you will notice something. And that problem we are going to cover then, or solve then, in the next part. Okay, so for example, adjust our interval of the physics system. For whatever reason, we cannot run it at 60 frames per second. Maybe that's too crazy for our game. We need to reduce it that it only runs 10 per second, which is totally fine for the physics simulation itself. And now when we move our player around, you see he's stuttering around. So this is not a very smooth experience and not nice for the player. And this is what I mentioned in the last part, which is this interpolation, which is currently missing in our fixed time step approach. And this interpolation we are going to fix then in the next part. But yeah, for now again, that's it. Thanks for watching and see you in the next part. Bye bye.